So you get the fact that graphing linear equations, you're going to get an equation, you're going to get a value for x, you're going to plug in the value for x into your equation, and it'll give you a value for y, and then you graph it. You graph your x coordinate with your y coordinate, and you graph it. And if it's a linear equation, the end result should be a straight line, hence the term linear. If you don't get a straight line, usually that tells you something went wrong, okay? Sometimes they'll ask you to test an ordered pair to see if it's a solution. So 3x minus y equals 7 is the equation, and they'll say, is the which of these ordered pairs is a solution for it? So you would test the ordered pair 3, 4. How does 3, 4 work? Does 3, 4 work in here? Plug in 3 for x. 3 times 3 is 9. 9 minus 4 is 7. So 3, 4 does not work. 1, negative 4, let's test that one. Okay, so 3 times 1 minus 4 minus a negative 4 would be adding the 4. Does that equal 7? Yes, it does. Therefore, 1, negative 4 would work as a possible solution. Okay? Why is this not the best option for testing out the equation? What is wrong with this potential linear equation the way it's written right now? Is there any other way we can work with that? Anything else we could do with that? Might make it a little easier. Not bad if we're already testing it, but if this were a linear equation and I wanted you to solve for it, what would be the issue? They should all equal y. This doesn't equal y, it equals a 7. What can I do to this equation so that it equals y? Can I move this around so it equals y? Mark. Let's add y to both sides, right? So what I have is 3x is equal to, can I just go y plus 7? Okay, they're both positive. Now what? How am I going to get y by itself? Yeah. Subtract the 7. Good to go. If you look, Raven, I've got two sides. I want to get that y, so it's just y. What's attached to it? And how do I get rid of a positive 7? Subtract it. So I subtract it there, then I got to subtract it from the other side. What was the solution we said worked? What was it? 1, negative 4? Plug in the 1. That would be 3, right? 3 times 1 is 3. What is 3 minus 7? So I had the 1 for x, negative 4 for y. So maybe asked to do that today, where they'll give you an equation, they'll say graph it, but they won't have it set up as y equals. Okay? So we may have to do some rearranging. Oh, right on cue. Top of page 216. So our first linear equation that they want us to graph, and for the most part, the values for x that are going to be given are the ones you used for today too. Negative 2, negative 1, 0, 1, and 2. Now the next step then is to obviously let's solve for y. So let's get y by itself. Now, I've got a couple options. If I move y right now, I'm going to have to do what? If I want to move y, I'll have to subtract it, and I'll end up with what kind of a y over here? Do I want a negative y? Let's keep that where it is. Let's get rid of this negative 2x. How am I getting rid of a negative 2x? Let's add it. So let's see. I'll have my y. So if I add 2x, that's now a positive 2x minus a 3. Are we set there? Are we good to go now? Okay. Any questions how we got from here to there? So let's plug it in, see what we get. So let's plug in a negative 2. So 2 times the negative 2 is negative 4. Negative 4 minus 3. So my first coordinate is negative 2, negative 7. Use the 2, negative 1, minus 3. 2 times negative 1, negative 2 minus 3. Plug in the 0, minus 3. Plug in the 1. Two minus 3, negative 1. And then finally plug in the 2. 2 times 2 is 4, minus 3 is 1. Okay? Any questions? Any questions how we got from the start to where we are now? No? If you want to try? Just give me the first step. Just convert and solve for y, and then raise your hand when you're to make sure we're on track with that. All right, so let's plug in the negative 2. Negative 3 times negative 2 is a positive 6 minus 2, 4. Good. Negative 3, negative 1 minus 2. 3 minus 2, 1. Negative 3 times 0 minus 2 equals negative 3 times positive 1 minus 2. So that's a negative 3 minus 2. And then negative 6 minus 2. You start to see patterns. Sometimes they're a little more evident than other times. What's happening to each time here? Yeah, you're subtracting 3 each time, especially if we take these in order, numerical order. Okay, so we should have something. If I got a negative 2, 4, negative 1, 1, 0, negative 2, 1, negative 5, and 2, 8. Your line should go somewhere like that, right? Somewhere in that neighborhood. Yeah. Okay. Sometimes you'll see some crazy looking linear equations like y equals 2. Okay. How do you graph that? Any ideas? Does it tell us what x is? Is there any x value there at all? It doesn't matter as long as y equals 2. Where is 2 for y? Y equals 2. Y value on any of these points is always going to be what? 2, just like they're asking. So if you had an x equals -1, be the same kind of concept. Here's my -1. Be just a vertical line. All right, so page 219. Let's do numbers 11 through 18. But I want to look at, let's focus here quickly on number 15. Because the way that you're going to get a y equals equation for numbers 11 through 14 are going to be very, 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 very similar to how we've been getting them in class. You already have just a regular y. Do you see that in 11 through 14? All the y's are positive. So really, it's just a matter of moving what else on that side that, so for 11, you're going to move the x, right? So you're going to subtract x from both sides. You'll get y equals what? -x plus 2. 2 minus x can be used. It's just not as easy. Just not as easy to do. But if we look at 15, 2y minus 6x equals 10. Okay? And we need to start shifting stuff around. Any recommendations? Yeah. Not yet. You're a step ahead of me. Still have to clear out this side. Let's clear out this side. Raven? Let's add 6x. Okay, Mark? Okay. Now, in order to get y by itself, yes, I'll have to divide by 2 because the 2 is attached with the y. So from there, y will equal, can both of these be simplified? Are they both even? So I should have what? And you're set. Okay? How about 16? How about 16? Raven, first thing. So how's this side going to look? No. There we go. Okay. Now what? Mark? Divide by 3. Here's where it gets just a little bit hairy. All right. 3y divided by 3 is going to be a y. And what's the issue on the other side? What's the potential problem there? The problem does it give us? Mark? Okay. The 4 is not divisible by 3. So I've got options. Okay. Now I can keep it the way it is. I can keep it the way it is. Or I can say a -4/3 x plus what? These are divisible. 4. Yes. Well, that's the question you want to ask yourself. So let's take a look at both of these, okay? Because essentially, whether I use this one or whether I use okay, it doesn't matter because why? No pun intended. Did I accomplish my goal and did I get y by itself? In both cases, I got y by itself. Okay? So, let's take this first one, okay? We'll call it option 1. Option 1, option 2. So let's take that that first value, which is -2, right? The first value we're going to use. So let's use option 1, and we'll say -4/3 times a -2 plus 4. Okay? That's how we'll set up that first one. Now, I'm multiplying with a fraction, which means if I do that, everything has to be in what form? So let's say -4/3 times what? What is -2 in fraction form? Okay. So negative times negative is going to give me a positive anyway, right? Nothing in common diagonally, so I'm going to have a positive 8/3 plus a 4. Say, oh my goodness, now what? Well, it's really not as bad as it looks. Why? Eight over 3 might be a little bit easier to work with if I'm adding to another whole number if I convert that improper fraction to what? So what is it as a mixed number? 2 and 2 2/3 plus 4. Add the whole numbers. Now, it might be a pain in the neck to graph 6 2/3, but can you do it? Can you do it? Yeah, it's just going to come between 6 and 7, and probably just a little bit closer to 7 than it is to 6. Yes, sir. We'll have to do both. So that's option 1. Let's look at option 2, okay? We'll use the same, and we'll say, what was option 2? -4x plus 12 over 3, okay? So we'll plug in that -2. All over 3. Okay, check this out. -4 times -2 is what? Plus 12. 20 over what? Which equals? Bam! Now, which one was easier? Option 1, option 2. Door number 1 or door number 2? I think door number 2. Like, if it's me, I'm going this one. But, because I didn't have to mess around with all this multiplying with fractions. Kept it in there, multiplied it on top, then divided what I had by 3. Actually, all I had to do was put it as an improper fraction and then simplify it. How does option 2 work with the second one? Y equals -4x -1 plus 12. So we used our -2. Now we'll use our -1 all over 3. -4 times -1 is positive 4 plus 12. 16 over 3 equals 5 1/3. How about your 0? So 0, 12, 12 over 3. Right, not so bad. Right, let me modify the assignment a little bit. Let's do page 219, and let's do 13 through 17. How's that? A little better? Have fun with that. No, really, have fun with it. How excited you got when you found out that option 2 worked the same as option 1. Wasn't that, it just make your day?